All right. All right. So you are basically, I would say, done with the first section of deep learning. Okay, you've gone, you know how to build a deep neural network, you know how that works, you know all the basics of how to do that in PyTorch. Now we're moving to, let's say, advanced deep learning, okay, if you want to call it that, or more advanced, right? Where now we take what we have learned, but the architectures are going to get a little bit more complex, right? The algorithms have something new in them, right? You know, they have, transformers. Transformers have like 40 different ideas that are added to the already existing ideas of deep learning. One very prominent one is the attention mechanism itself, right? There's something called attention. It's a type of a thing that you use. At the end of the day, some kind of a matrix multiplication again. It's always some matrix multiplication. All right. So transformers are something we'll cover. GANs are a very, very nice thing that we will cover. But today we're going to start with CNNs, right? Convolutional neural networks, right? So that's what I'm going to cover now. I'm going to give you a little bit of a description of them. Theoretically speaking, I'm going to give you a bit of a motivation for them and what they are, right? To motivate the idea. And then we're just going to get into the code and how to implement it. And you'll see it's actually pretty much you already know how to do it except for the architecture. Okay. So I have two things that we're going to use to kind of get an idea of, or three things, right? So I want to show you these links so that you can find this stuff if you want to look at it again, right? So the code that I'm going to describe today, it's already on the GitHub. You can find it in PyTorch and the deep learning CNNs, MNIST CNN Torch. Usually I make modifications to these scripts, so I may upload a new version, when we're done, okay? But basically it'll be a lot like what is already here, okay? And as I said, even though the challenge is for Sci-Far 10, I'm only doing this for MNIST as I want you guys to do a little bit more of the coding this time around, okay? Second thing I want you to know is I have a PDF document that I'm going to be using for this description of convolutional neural networks. So you can find it at this URL. This is free for you to use. And this is where my notes basically on how a convolutional neural network works. All right, this will be the theoretical framework that I will be discussing. It's only a few pages, okay, like 4 or 5 pages. And there's a diagram there that summarizes everything. So note the link, okay? And then the third thing is you can go here to the GitHub again, Machine Learning Foundations, Neural Nets, NN's Math. And basically here, we're going to take a look at math's convolutions, okay? And it's basically a way for you to kind of understand what's going on, okay? So I wanted to note the 3 URLs. I'm going to start here with NN Maths. So a convolutional neural network is a deep learning algorithm like the one we have already written, except that there's an additional set of layers in the model, okay? And that layer, usually everything is a matrix multiplication of X times weights, right? That's basically what we're doing. But now in the CNN, we have this new operation, which people call the convolution, all right? This comes from math, from decades of mathematics, right? Where these operations have been done, okay? So I would describe it formally, but I also want to give you an intuition of what is happening, okay? I think we talked a little bit about this when we discussed the feature engineering slides last week. If you remember, what I said was 15 years ago or so, or 20 years ago or more, what was the basic pipeline? People would take an image, and then they had 20 to 30 filters that had been developed by very smart people over decades, right? And they had like plugged in, if we put these values, and then I'm going to run this filter, through an image, and guess what? I modify that image to another image. But the filter does something pretty important, and so it highlights some aspect of the image, right? It highlights the edges, so there was a filter called for edge detection, and there were all kinds of averaging filters and wavelet transform filters, and they got pretty complex, okay? But these were done by humans. As we will learn, so the pipeline was input, run it through filters, modify the images, and then use it in some classifier, train a classifier. Nowadays, the CNN does all of that in one shot. So you give it an input, you give it layers, you give it filters, but the filters don't have values, don't have predetermined values. Instead, you only have random values in there initially. But it's basically, you can think of it as the filters are weights that we need to learn. So as we are feeding it an input in a class, and we have millions of records in there, the model learns, and guess what? Those filters actually become pretty good. They take the image, modify it, give you another image, and then you use that information to classify, you predict the value, compare to the real, update the weights through stochastic gradient descent, and you just keep doing that until you're done. Does that make sense? All right, so I want to give you some insight into this idea of the filters, okay? So I've written this code here, and I wrote it in a very non-efficient way, which is basically using for loops. But the reason why I did that is so that it's very obvious what's going on. I'm not going to demo this in class, but if you guys, I do recommend that you do this on your own, just to kind of to get a good feel for what's going on, okay? So just click on Maths, Convolutions, and basically, this is not deep learning or anything. This is just, if anything, image processing. It's the kind of thing that if you ever took an image processing class, probably you would do this, all right? Running filters through an image. But that is a good way of understanding what a convolution is, all right? This mathematical thing that's defined and done for you in PyTorch, okay? So maths and convolutions, so you can see I'm using, there's a very nice data set called skimage, I guess. So it's like scikit-learn, but for images, and it's got some data. And basically, you can see I've brought in some libraries here. So what I'm going to do is, and you guys can play with this, is you can have images, run filters through them, and modify the images, okay? So that's kind of what I want to show you here. So I have an original image from this data set, which is a cup of coffee. Notice it's not that big, okay? And I'm plotting it here basic. You guys see that? So what would you do now? You would run a filter through it and modify it. Do you see that? So here is my filter. You see that one? That's a filter, okay? Notice the image is 64 by 64, and the filter is 3 by 3, okay? This is how CNNs work. You define the size of a filter, and that filter is going to run through every pixel in the image and modify that pixel based on the, I guess, the 8 pixels around it. Do you see that? And it's gonna base, it's an equation you can see that uses these values to modify it. So here I take the filter, I take the image, and notice I have 2 for loops, which I have said many times is very inefficient, right? You should do this with NumPy, right, to be more efficient. But I have it this way so that it is absolutely clear what's going on. Okay, and what you're doing is you're modifying the images based on the filter here. So once you do that, notice that the image is no longer the original one. Do you see that? It becomes this image. Interestingly, it's like it highlights some aspects of the image and it ignores other ones. So in this case, this is called a horizontal edge filter. Okay? So in theory, what's it doing? It's highlighting horizontal edges. Do you see what I'm saying? Why is that relevant? I don't know. But maybe you need to know Okay, what are the horizontal edges? What are the vertical edges? And from there, the neural network starts building an understanding of the image itself. Because you run this through layers. So, you would run a horizontal filter, a vertical filter, and then the combination of those things are a new neuron that looks, okay, if there's a horizontal filter, there's a horizontal edge and a vertical edge, then I know what this is. Do you see what I'm saying? Okay, so that's a convolution. Literally, I'm giving you here exactly what a convolution, the meaning of it. You're running this filter through the original image to get another image. Got it? All right. So that's the horizontal filter. Pay attention to this fact here. The values are pre-populated here. In a CNN, they are random values that must be learned. So the power of that is that if you don't need a horizontal edge filter, it's not going to learn a horizontal edge filter. Maybe it directly picks lines that would make an eye. And it's going to pick those lines that, when combined together in future layers, make an eye. You see what I'm saying? That's the intuition. All right, so that's a horizontal edge, and that's the output. Then there's a vertical edge detector or filter. Notice that the values in this one are different from the values in this one, but they are already pre-populated. Okay, so you run that through the image, aka the convolution, and what do you get? You get another one. Do you see the difference in these images? Pay attention here. So here I have the original image. Here it highlighted this, right? The horizontal line or curve. This is a vertical edge filter. By just applying this operation, look at what it did. It picked up this curve and not this curve. Do you see that? So here's the interesting thing, Lenny. You create a horizontal filter and a vertical filter, right? And that's like saying two neurons. In the next layer, the neural network may actually make the connection for you. So it takes the output of horizontal and the output of vertical, and you know that those will go to the next layer. And one neuron may connect them. So it activates horizontal, vertical, and combines both of them to have to do what you want to do. And you didn't have to do it. That is awesome. I agree with you. That is what neural networks actually do. They learn stuff, right? And this is the power of adding more layers, that they can pick up on two things that are, for detecting a coffee cup, it might be a good idea to look at horizontal and vertical curves, right? And then it can detect the coffee in there. Got it? All right. So anyway, again, I repeat, the reason why I give you this is to give you the intuition of what a convolution is. You can see right there in the code. You can go run this. The filters are predefined here, and a CNN would need to learn these. Okay. When we use ResNets, for instance, if you take 530, we use a ResNet. It has the values of the filter already in there, but no human had to go in and type them in. Instead, they were learned over training, right? So it's like you take millions and millions of images, maybe Google did this, right? And then they had a really advanced CNN, and they trained it over many, many months. And these filters were learned automatically by the model. They weren't like here where they're crafted by a human. And then now what's the value of that? Whenever you fit an image, it's going to go through the entire ResNet and give you an output vector which has all these filters. So it has detected edges or curves or eyes or whatever it is. And then after that, you can add more layers just to do your classification. Because you might want a problem that has 3 classes, 5 classes, 10 classes. So you modify that yourself. But from input to where you process through all the filters, that's ResNet. Okay. Does that make sense? So that's like the state of the art. Okay. So that's, really powerful algorithm. Okay, so those are even more advanced than CNNs, but they're based on CNNs. So then, yeah, so you've seen that. Then we have a horizontal edge filter with stride 2. So those are just modifications. So if you notice, if you look at the resolution of this one, right, compared to the resolution of this one, you can see that the pixels are a little bit bigger somehow, more boxy. And that takes us to the important concept that CNNs also shrink the images. It's like they start with an image of a specific size, and then they start running these filters, but they also try to compress them, like cut them down in size. That's called max pooling, and it's something that yes, you flatten. There's going to be a flattening layer at the end. Yes, that is correct. But basically, you can think of the convolution as this process of running the filter, modifying the images, and then cutting them in size, like by half, for instance. Okay. And again, you can see that the values in the filter here are pre-populated. A CNN would have to learn them. And then, these are just more examples of it. But the goal of this, as I said, is just I do recommend run this code, get a feel for it, but it's just to give you the intuition of what a convolution is, because I know that my description of it is more like a math expression of it, which might be more abstract for you to grasp. But it is something like this. And this is just done through PyTorch. So PyTorch has a multiplication operation between an X and a W, or it has a convolution. So when we are doing a convolution, we use a convolution function where we have to tell it what the filter is, and we give it an input. Okay? Yeah, please. Does it have to be a 3x3? No, it could be a 5x5. So you specify the size of the filter. That's a good question. And we'll see that in the code, basically, that we do specify. Actually, since I just to tie it to what your question is, I have the CNN architecture here. So you can see this is the operation, convolution, where we specify to answer your question, that's the size, 5x5. So there's square filters, which are called kernels, by the way. And that's why it's called kernel size here. Got it? All right, so we'll come back to the code. This is really most of the code that we're going to write today, you should be able to do. And really, this is the only part that defines the CNN right there. That's it. If you notice, it's very familiar to what you've already done. And we're just introducing this new operation called convolution. Okay. All right. So I've gone over the intuition, which was this one over here. So I should be done with this example. So remember where it is, play with it. But that's basically it for that one. Okay. So now I'm going to go into a more formal definition of a CNN. Is it really?